This is already done. So, good morning and welcome everybody to our second webinar this week. As you know, my name is Elizabeth Lasu and I am the Head of Sales and Marketing at Fesia Technology. Today, we will focus on Fesia Grasp, a unique device for upper limb rehabilitation. The webinar will be structured in a brief introduction about the company. Later, Aitor Martin Obriozola, Clinical Applications Manager, will share the scientific evidence on FES applied to our limb rehabilitation. And finally, Aritz Zabaleta, CEO, will describe the technology and the characteristics of our device. You will have the opportunity to ask questions by using the chat, and we will try to answer them at the end of the presentation. In any case, there is always a possibility of using our account info@fesiatechnology.com if you need to forward anything to us. And of course, as I was mentioning before, if after the presentation you want to have an open discussions, any of you is welcome to ask questions. We will be happy to answer. So perhaps there are some people in this webinar who do not know us. So I will go very shortly through a quick presentation about the company, and then, as I said, my colleagues will continue with more technical information. So, Fesia Technology is a Spanish company located in the beautiful city of San Sebastian at the Atlantic coast, 20 kilometers away from the French border. Our headquarters is situated at the Technology Park of Guipúzcoa, a specific surrounding for high technology organizations. The company itself is a spin-off from Tecnalia, the second biggest research organization in Spain, with over 1,500 researchers in different fields. Tecnalia has a dedicated unit for neurorehabilitation technologies, and already in 2010, this organization started developing different projects in the field of FES. The outcomes of these projects in the form of patentable technology contributed to the decision of establishing a new company, Fesia, that would, with the purpose of bringing the technology to commercial products. In 2018, the CE mark for Fesia Walk and Fesia Grasp were granted, the ISO 13485 obtained, manufacturing authorizations were put in place, and the commercial activity was started. Currently, the company is expanding this commercial and sales activity to different countries. Fesia products are already available in over 15 countries in the world through an expert team of sales partners. As the origin of the company is within a research organization, you will very well understand that scientific evidence is in the center of all our activities, and this can be seen in publications such as PhD theses, patents, articles, studies, presentations in conferences and different venues.
And as my colleague Elizabeth has said to you, I am the Clinical Applications Manager of Fesia Technology. In the next few slides, I am going to give a short summary of the scientific evidence available today about the use of FES for the treatment of upper limb. In this image, you can see the pen-filled homunculus in which the different parts of the body appear in the proportion that they represent in the cerebral cortex. This allows us to realize the importance of the hand in the cortical sensitive and motor representation. In addition, problems in the upper extremities appear in more than 70% of people with CNS diseases, having a significant impact on functionality and quality of life. That is why new strategies like ours are necessary to treat these patients. To date, there are 14 published randomized clinical trials studying the effects of FES treatment on upper limb rehabilitation most of them done with stroke patients, measuring many different outcomes. Large improvements have been seen in Fulk-Meyer assessment, up to 27.2 points, motor activity log, functional independence measure, up to 22.8 points, and Barthel index. Also in functional tests, like in box and block test, up to 48%, Jabson-Taylor hand function test, upper extremity performance test, action reach arm test, and so on. The motor activity measured by the Brandstrom recovery stages and motricity index is also improved. Finally, increases have also been found in the range of motion of the joints of the hand and the fingers, and improvements in spasticity measured with the Ashworth scale, having a reduction up to 56%. In addition to having studied the use of FES, studies have also been done combining it with different therapies, such as these ones, mirror therapy, botulinum toxin, bilateral arm training, task-oriented therapy, or action observation plus brain-computer interface, for example, showing in all of them promising results. To conclude, mention that, as you can see in this slide, the most important scientific societies in the field recommend with one evidence level the use of FES for the treatment of upper limbs. And now we'll start speaking Aristabaleta, our CEO, starting by the FES technology.
Okay, so thank you very much for the introduction. As you all might know, the origin or the electrical principle of our central nervous systems, nerves, and muscle activation is a very well-known and very old knowledge and concept. So, but it is not until 1967 where the first conception of a device is described in a patent. In this case, is a foot drop lifting device concept that it is patented. It is quite a rudimentary description, but in the 90s, very well and remarkable scientists approached the functional electrical stimulation and the influence of each of the parameters that are included in the generation of this electrical impulse, derive in a series of products that in the late 90s show up in the market. And of course, due to the difficulty or the complexity of the upper limb, if we compare it to the complexity with the lower limb, the upper limb products, of course, appear later in time. We, in 2019, launched the Fesia Grasp system. That is the main focus of this presentation. Well, how do we contribute beyond what it is known, the state of the art? One of the main characteristics and obvious differences is the multi-field FES technology. Well, it's a very good thing to have in terms of engineering, but how do we contribute as a product? How does this technology contribute to a better product than the one that exists? Well, first of all, we reduce the donning process. So basically, we do not need to find the optimal stimulation point anymore. We just place the system in the forearm, and then with the application, we will find that optimal point. But we do not need to set it on, try and set it on again, and try and error. Is a very time-consuming process, and we reduce that significantly. Of course, we also have a very tiny areas, as you see in the picture, and each of the areas can be activated individually. So we have a higher selectivity, which end up in a better clinical outcome in terms that we can reproduce the hand function in a more natural way. We also, and I will go deeper later in the presentation, we also have the usability always in mind when defining and designing these products. But at the end of the day, ends up having a higher adherence of the patient to the treatment, and therefore we can also deliver higher dosage of treatment. And of course, but this applies to many other technologies as well, like robotic rehabilitation and so on. The repeatability and the intensity of the therapy is increased comparing it to the manual procedures. I want to show you a picture of how the Fesia Grasp system looks like when you receive it. When you receive it, I wanted to show you this because we always had in mind the usability, the design, the easiness of use in mind. Not only when designing the application, but also the carry case, also the application with which goes the tablet application that goes with it. So first and most importantly, we have the usability, the reduction of time when donning the system was a key feature or key design factor that we always had in mind when developing this product. I will show you a video how it is used, so that you very easily have an idea of how it's used. First of all, you of course need to place the garment with the electrode in the forearm. This, of course, it's a fake wooden forearm, but it does show how it looks like. And you peel off the protection layer of the electrode, that is the electrode part with each of the areas. You place, and it's a textile flexible garment that you place easily. The garment has its own landmarks in the wrist and in the elbow, so that it makes you, it guides you towards the correct positioning of the system. And once you have it placed on the forearm, you connect or put the stimulator on, and of course you turn the stimulator on. Once the stimulator on, then you can use the application in order to configure each of the primitives that you want to use that given day with that given patient. There you can see the index extension, for example, but I will go deeper afterwards in the explanation of the application. So the parts that comprise the systems are, of course, the textile. There's a left and a right garment, of course, for left and right affected patients. And there are also left and right electrodes. And the indication is that you use one electrode per patient due to the hygienic reasons, basically. And there's also, of course, the stimulator. There is also only one stimulator. There are not two stimulators, two systems, one for left, one for right. So the kit comes all with left and right garment and electrodes, plus a single unique stimulator that can handle both types of patients. And of course, it comes with a tablet with a pre-installed application and configuration, and of course the charger, standard micro USB charger, medical degree charger. So this is how the multipad technology looks like. So comparing it with the traditional 1-to-1 FES electrode, you have the black one is the anode, the red one is the cathode. Well, then this is there's a debate of is electrode and counter electrode. It doesn't matter, but in our technology, you only need to say which area you want to use. The anodes are automatically selected from the areas you want to you wish to stimulate. So again, there's some automatism. There's a lot of algorithmic behind that, and there's of course a lot of clinical research behind that on how to use how to make it easy to use. Okay, so the most remarkable aspects, I think, it's or what our clients and physiotherapists and users told us is that you have a free palm, so you have a free hand that can you still can have a wrist function, so that you can do functional exercises, grabbing things or drinking whatsoever exercise, and very important factor. We, due to the selectivity, can reproduce a more natural grasping function. We go more in detail afterwards, but we can reproduce 3 types of grasping functions. Very easy and quick placement, donning process from the very early point where you start using the system. So it's when you take it out of the shelf and take it out of the box. Every step is very well thought, and it's quick and easy to master. And there's of course the comfort side of it. So we of course have designed the garment with textile experts, and it is a textile that is very robust to scratches. You can put it in a washing machine, no problem at all. But at the same time, it's a very comfortable and flexible garment. And well, it's an important factor, but it's a totally wireless system. It cannot be any other way in the 21st century. So. Of course, everything comes with the Fesia Pro application. This application is thought for a clinical use. So basically, the therapist has a set of what he can create or she can create patients profiles, and when patient A or B comes, selects that patient and all the parameters that are for that patient, laterality, and the parameters that fit best for this patient are uploaded and sent to the stimulator automatically. So you don't have to note down, remember, or do anything. This profile is uploaded to the application, and this is sent to the stimulator. In the Fesia Grasp case, we have 2 types of protocols. One is the training protocol, and the other one is the gait or grasp protocol. In the training protocol, we have pre-selected which areas provide a flexor stimulation and which areas provide a extensor functionality. No matter if it's a wrist extension, thumb extension, or finger extension. So what this training protocol does, it selects 1 or more areas of one group, stimulates them for 5 seconds, relaxes the muscles, and then switches to the extensors. So we flex and we extend, flex and extend continuously in a given number of repetitions that you, of course, can select. This is the kind of parameters that are stored in the patient's profile. For one patient can be 5 repetitions, for other one can be 50. So these are stored in the patient's profile. And then there's this grasp protocol. The grasp protocol is done in two steps. One is the configuration step. Basically, what you want to do is to configure which areas are selected for that given patient, depending on his forearm size and many other factors, which areas are going to be used for each of the primitives. We call primitives to individual functions of wrist and finger. In this case, this is wrist flexion, wrist extension, thumb flexion, thumb extension, external finger extension and flexion, and index finger flexion and extension. So basically, for each of the groups, you are not obliged to go through all of them. You can select which areas fit best for that given primitive. Once you have selected each of the individual primitive, you can then schedule a training. You will see a detail afterwards in the next video. So the more primitives you configure, the better the hand function will be. So the sequenciation of the hand opening and hand closing is the sum and timing schedule or program of each of the primitives. So the more of them you configure, the better outcome you will have. And next, of course, we still in that small settings, or we still have some advanced options. So for those persons that really master and know very well the effect of those pulse width and mostly pulse width and frequency parameters, you can very easily set them higher or lower. And once again, these parameters are stored in the patient profile, so you don't have to remember them in the next session of that given patient. And last but not least, we also have the capability of showing what the evolution of those parameters have within time. So you select the patient and go to the report report button, and it will show you how the intensities and the stimulation parameters evolved within time from one session to another. This is a very important factor because it's an indicator of how the patient is evolving, whether his motor threshold is lowering down, whether he's getting used to this stimulation, and therefore you can go higher. Not used in the clinical term of the habituation, which is an effect that you don't want to have. In the FES happens totally the contrary. The more you use the FES, the less intensity you need in order to get this functional outcome. So you need less and less and less intensity within time. So if this indicator goes down, it's a very good indicator. And also we included the functionality of being able to record the whole or even parts of the session for the patient. So if you are in the middle of a session, you can use the same tablet and record a small section of portion of the session, and then afterwards you can compare within different sessions how the range of motion, or how in the case of Fesia walk, how the patient is walking, or how the patient is how fast or how confident, those parameters that are not so easy to evaluate. Grab a glass or do certain exercises for them. So I'm going to show you next a real video of what the rehab looks like. Once the primitives are configured, you will see in the application how there's also some visual feedback of what the stimulator is trying to well, is stimulating actually. In this case, it's a finger extension, and thumb extension. So once you select the primitives, you select which sequence you want to execute, and this is a carousel that you can repeat. Just start the session, and you can repeat once again that sequence. So I hope this is some kind of clear for you how this system works, and the system, how the system is, and we are open to any questions you might have. So please feel free to ask anything you.
We have a question here about whether the product is commercially available. Yes, the product is 100% commercially available through our net of sales partners. So if any of you is interested in the product, please send us an email. I think that the audio is not very good, so perhaps somebody else can answer the questions. Yeah, if this is not working well.
Yeah. Yes, regarding the second question, where can I see the videos again? These videos are available in our YouTube channel. So we have different lists. One is the webinars, where actually this webinar will be also uploaded. But you can see use case videos also in our YouTube channel. Yeah, I will provide you the link immediately. While I search for the link, Aitor, you can maybe answer the question about the improvement of patients and so on.
Yeah, regarding this question, the improvement depends on the patient and on the time that that the patient does the treatment, but the improvements are in the evidence part of this webinar, which I have explained before. If you want, we can send you the references of the papers. And in regarding the time, it depends also on the patient, on the intensity and intensivity of the treatment. So I only can say that it depends on the case.
Okay. It has to be used by professionals only. Well, in the actual conception of the product, this is thought for a professional use only. In the Fesia walk system, we have, but only from the regulatory point of view. We also, this system can be used at home also. So we also have the ISO 60601 111, so which allows us to sell to private users only. But we always recommend, of course, that this is used, or at least informed with his or her physiotherapist or health professional, of course. Well, thank you, Ed, for your question. We, of course, are very open to collaborations with in the research field, and we are open to provide some communication means so that you can modify but this would be a research use only device. So clearly, yes, we are open to collaborations with universities and research, and we have our internal SDK, and we modify it depending on the collaboration we have each time. So please send us an email, and we will contact you and start a conversation if you wish.
Regarding the next question, it can be used, of course, in several disabilities. If it has an spasticity lower than 3 or 4 in the Ashworth scale, but if this spasticity is lower, it can be used, of course.
Okay, so thank you very much for your comments. I'm sorry. What about possibility of EMG control stimulation? This device does not have a EMG acquisition system. Clearly, no. If you have your own EMG acquisition system and you want to do a closed loop control or so, well, the answer would be similar to it. We are open to collaborate in research projects that include EMG control. We know that EMG and closed loop control is a future trend. Actually, we are very likely working on that already, but yeah, no, for now, we don't have that functionality yet. Okay, so in any case, one can use a patient this system all day. Yes, actually, well, the indications and the limit of that is the skin irritation. From the concept point of view, this is not thought for a neuroprosthetic device yet, but you could use it all day long, but less than 24 hours. So there's a limit on that. So due to regulation, basically. So you can use it continuously for less than 24 hours. Yeah. Okay, so thank you very much. I appreciate your questions. If you have more, please contact us in info@fesiatechnology.com, and thank you very much.